We're going to look at some stuff on page 253. It's kind of connected to the example one that they have, but if you're given a graph like y equals negative 2x squared minus 6x plus 20, a strategy to find symmetry is sometimes you can find the x-intercepts or the zeros quickly. And it's as simple as just plug in y equals 0, and then all of a sudden you now have a question from our chapter 3. It's a solving question. If the y value is 0, could we solve? Well, I could divide everything by negative 2, and then I could factor, and when I factor, I get x equals negative 5, or x equals 2. So right away from the graph here, 1, 2, 3, 4, 5, that would be one x-intercept. 1, 2, that would be the other x-intercept. And right in between, somewhere, I tried to draw a dotted line all at once so I can move it back and forth. Oh, I think I have an idea. Let's go with a green dotted line. There we go. There's my axis of symmetry. Obviously, it is in the wrong place. If this is negative 5, and this is 2, it has to be right in the middle there. Where will that be? That looks pretty close. Is that in the middle? What is that? X equals, what is halfway between 2 and negative 5? And anytime you want to find halfway between something, you're just finding an average. What do you think it is? Negative 2.5. If I put in negative 2.5, that's going to be 2.5 away from 5 and 4.5 away from 2. As a way to check, right?
Negative 1.5.
And if I plug in negative 1.5, that's 3.5 away here and 3.5 away there. Now, anytime you're trying to find the middle of something, it's like the midpoint. Remember doing midpoint in grade 10? And a midpoint formula is just an average. Right? You get 70 on one test, you get 80 on the other test. What's your average? 75, right in between them. Okay? How do you find out your average? If you wanted to do it mathematically, you could add 70 and 80, get 150, divide it by 2 because you had 2 scores, and your average would be 75. Notice, what happens if you add negative 5 and 2 together? You get negative 3. What's half of negative 3? Negative 1.5. So what's really nice is if you find the zeros, you would find your axis of symmetry. And this one, as a decimal, probably wouldn't have been one that you would have found just with your regular table of values. So to highlight something here, right? Well, that's my little highlighter. Here's my bigger highlighter. We call the x-intercepts the zeros of the function because it is where the y value is 0. And by plugging in 0 for y, we go back one chapter and be like, hey, I know how to solve that. I can use factoring, completing the square, or the quadratic formula to do that. Some other things that are interesting and worth noting, this is at the top of page 254. Here they've got the parabola of x squared plus 4x minus 6 drawn. And they've got some interesting patterns you can notice. If the number in front of your x squared is a 1, you have 1x squared. First of all, because it's positive 1, this is opening up. And if it is a positive 1, you will always have the following pattern. Go from your vertex, and you might have noticed when I drew the first parabolas, I was using some sort of pattern to find other dots. This is the pattern I was using. You go over 1, up 1, then over 1, up 3, then over 1, up 5, then over 1, up 7. If I wanted to find the next point, do you think you're recognizing a pattern? I would have to go over 1 up, how much? You notice a pattern? Going over 1 up 1, then over 1 up 3, then over 1 up 5, then over 1 up 7. If I did it again, I'd go over 1 up 9. And this is true for any parabola that has a 1 in front of the x squared.
Send Megan to the office, please.
Yeah, she'll be right
Thank
down.
you.
You're going to find out if it's a 2, it goes over 1 up 2, then over 1 up 6, then over 1 up 10, then over 1 up 14. It just, if the number in front is a 2, then this pattern doubles. If the number in front is a 3, this pattern would triple. So for graphing a parabola, we're learning a bunch of little tricks. We learned about symmetry. We learned about the coefficient if it opens up or opens down. We learned how if you have symmetry, if you have 2 points that are the same, like the x-intercepts, right? As soon as I find these 2 points that are the same, -5 and 1, I can go and find the axis of symmetry will be right in the middle between those two. So we're learning a bunch of patterns that can help us graph. Okay, let us see if we can use those patterns and figure out, do these tables make a parabola or not? And how can we tell? So your basic parabola, starting from your vertex, over 1, up 1, over 1, up 3, over 1, up 5. What do we know about a basic line? The over 1 up in a line, that's your slope, right? In a line. And that always stays the same. So here, notice I go up 1 and I go down 3.5. Then I go up 1 and I go down 3.5. And then I go down 3.5. And then I go down 3.5. Because every time I went over 1, I went down 3.5. That makes a perfect straight line. So does that one quadratic? No. That is a linear function. And the second one. We go over 1, and this time we're going up 8.5. And then, oh my goodness, another line. We would need to see that 1, 3, 5 pattern in order for it to be a quadratic equation. This time, every time we go up by 1, we go up by 8.5. This would not be a quadratic. Did the textbook give any ones that are quadratic? Yeah, they do. You can see in the example of the textbook that in the second example. And one thing that's sort of going to be related to calculus, what's interesting about, so I'm going to just for fun, I'm I'm gonna take x squared, right? Here's y equals x squared. And we have 0, 0, then 1, 1, then 2, 4, then 3, then 9. And we get the pattern of +1, +3, +5. And the textbook is already talking about those as being the first differences.
Mr. Roberts to the front foyer, please. Mr. Roberts to the front foyer.
But then if we look at how these ones are changing, now they're the same, going up +2 each time. If the second differences are always the same, you will always have a quadratic function. If the first differences are the same, like the ones that we did, you'll always have a line. If the second differences are the same, you will always have an x squared. What do you think you'll have if the third differences are always the same? An x cubed graph. So only one question to circle on this one. Question number 6.